All right, so in this lesson, we are going to identify and interpret slope and y-intercept again of a linear situation, linear relation, given a table, but this time we will have some decimal values. So, situation 1, Eva is frozen cold. Andrea starts moving her around Eva, and Eva's temperature starts to rise. Her temperature increases at a constant rate. So, y-intercept is when the independent variable is 0. So 0 and 10. Oh, that was easy. And so she's frozen cold. Her friend Andrea starts moving her around. So this is the temperature of Eva. Yeah. So Ava starts at 10 degrees. Or we'll say it like this. Ava, no, in the beginning, I almost forgot. I almost forgot how many ends there were. In the beginning, Ava's temperature was only 10 degrees Fahrenheit. Cool. Let's figure out the slope. So the change in temperature, or the change in seconds, change in time. I don't want double T, so I would put S for seconds. Okay, we are trying to figure out how the temperature changes according to the change in time in seconds. So let's pretend I didn't know how to get from 10 degrees to 10.20 degrees, or 10 and 20 hundredths degrees. I would have to do 10.20 minus 10 degrees is 0.2. So we increase by 0.2, and you can see it again here. 0.20. I'll put 20 right there. That happens when the time increases by 4. Now, since it tells us constant rate, we don't have to keep doing this. I only really need to check it one time because it's going to be constant. So the change in temperature over the change in number of seconds, or time measured in seconds. The temperature increased by 0.20, or 20 hundredths of a degree, every 4 seconds, or when the second increased by 4. So positive or positive is a positive. Yeah, so I have to write that. I'll put 0.20 over 4. So let's go ahead and figure out what that is. So let's go with our new decimal. Desmo, assign to the calculator. 0.20 over 4. And then you can just click this convert to fraction, 1/20th. So 1/20th. 1/20. Because the whole point is we don't care for this decimal. I want you to put it in regular fraction like form, reduced fraction form. And 1/20th, when you do it in your calculators, 0 and 5 hundredths. Let's interpret this. So the temperature, Ava's temperature, increased by 1 degree when the time increases by 20. Remember, we're going to use this one right here. I'm gonna do this. The temperature increases by 1 degree when the time increases by 20 seconds, is it? Yeah, seconds. Cool. So we were talking, the dependent variable is the temperature. The temperature starts at 10 degrees and it increases by 1 degree every, or one, okay, the temperature starts off at 10 degrees and it increases by 1/20th of a degree every second. That's gonna be hard to make not look like a 5. Every second. Or you can say the temperature starts off at 10 degrees and increases by 5/100th of a degree every second. That one's a little hard to see or differentiate. Let's do another. So Gerardo has a pool with gallons of water. John pokes a hole in the pool and it starts to leak. The water leaks at a constant rate. So we know there's constant rate. Remember, if we have trouble here, then we subtract going backwards. Like here, 10 to 10 and 20/100ths. We did 10 and 20/100ths minus 10, and we got positive 20/100ths. So I'm going to do 97 minus 98.5. And then that gives me negative 1 5/10. So this is what it gives me. So that's minus 1.5, which makes sense. That's why, remember, always, if you're trying to figure out what you did going forward, you go in reverse order. And this is just plus 2. I could do, oh man, I could have done this easier one right here. Minus 3 and plus 4. Oh well. So that's change in water. So I'll change in the amount of water. And this would be change in minutes. All right, because we're trying to get to 0. Remember, our goal is to get to 0. We're trying to get to 0. So plus 2. Oh, yeah. The 2 helps because we're going to go back to. So instead of minus 1.5, I'm going to add 1.5. So that gives me 100. So 0, 100. My y-intercept is 0, 100. And so Gerard has a pool. John pokes a hole, starts to leak. Okay, so the pool starts with 100 gallons of water. Cool. The slope is the change in water over the change in number of minutes, change in time, right? So the water, let's just use this first one, decreased by 1.5 gallons every 2 minutes. Negative over positive is a negative. Remember that we don't want to leave it like this. So let's check Desmos. How do I, there we go. Oh, I'll try this. So negative 1.5 over 2 is negative 3 over 4. Oh, and that makes sense because negative 3 over 4 right here. See? You should have just used that one. Which is negative 0.75. So the amount of, I'll write that a little bit nicer, especially if I'm abbreviating it. The amount of water decreases. Remember, we're going to use this nice one right here. decreases by 3 gallons when the number of minutes increases by 4 minutes. You could have also said when the time, which is probably what I should have wrote, you know? So ultimately, our dependent variable, we care about the amount of water, gallons. So the water starts with, the amount of water is equal to 100 gallons minus 3 gallons, or minus 3/4 of 1 gallon every minute. So the water starts in the pool starts at 100 gallons and it decreases by 3/4 of a gallon every minute. Or we could say that the water in the pool starts off at 100 gallons and it decreases by 75 hundredths of a gallon every minute. And that is it. Thank you.